In planar geometry, an angle is the figure formed by two rays, called the sides of the angle, sharing a common endpoint, called the vertex of the angle. Angles formed by two rays lie in a plane, but this plane does not have to be a Euclidean plane. Angles are also formed by the intersection of two planes in Euclidean and other spaces. These are called dihedral angles. Angles formed by the intersection of two curves in a plane are defined as the angle determined by the tangent rays at the point of intersection. Similar statements hold in space. For example, the spherical angle formed by two great circles on a sphere is the dihedral angle between the planes determined by the great circles. Angle is also used to designate the measure of an angle or of a rotation. This measure is the ratio of the length of a circular arc to its radius. In the case of a geometric angle, the arc is centered at the vertex and delimited by the sides. In the case of a rotation, the arc is centered at the center of the rotation and delimited by any other point and its image by the rotation. The word angle comes from the Latin word angulus, meaning corner, cognate words of the Greek gamma kappa upsilon lambda omicron sigma, meaning crooked, curved, and the English word angle. Both are connected with the Proto-Indo-European root *angle, meaning to bend or bow. Euclid defines a plane angle as the inclination to each other in a plane of two lines which meet each other, and do not lie straight with respect to each other. According to Proclus, an angle must be either a quality or a quantity, or a relationship. The first concept was used by Eudemus, who regarded an angle as a deviation from a straight line, the second by Carpus of Antioch, who regarded it as the interval, a space between the intersecting lines. Euclid adopted the third concept, although his definitions of right, acute, and obtuse angles are certainly quantitative. Angles between curves. The angle between a line and a curve between two intersecting curves is defined to be the angle between the tangents at the point of intersection. Various names have been given to particular cases: amphiceatic, cissoidal, biconvex, xystroidal, asystroidal, concavo-convex, amphicelic or angulus lunularis, biconcave, bisecting and trisecting angles. The ancient Greek mathematicians knew how to bisect an angle using only a compass and straightedge, but could only trisect certain angles. In 1837, Pierre Wantzel showed that for most angles this construction cannot be performed. Angles in geography and astronomy. In geography, the location of any point on the Earth can be identified using a geographic coordinate system. This system specifies the latitude and longitude of any location in terms of angles subtended at the center of the Earth, using the equator and the Greenwich meridian as references. In astronomy, a given point on the celestial sphere can be identified using any of several astronomical coordinate systems, where the references vary according to the particular system. Astronomers measure the angular separation of two stars by imagining two lines through the center of the Earth, each intersecting one of the stars. The angle between those lines can be measured, and is the angular separation between the two stars. In both geography and astronomy, a sighting direction can be specified in terms of a vertical angle such as altitude, elevation with respect to the horizon, as well as the azimuth, with respect to north. Astronomers also measure the apparent size of objects as an angular diameter. For example, the full moon has an angular diameter of approximately 0.5 degrees when viewed from Earth. One could say the moon's diameter subtends an angle of half a degree. The small angle formula can be used to convert such an angular measurement into a distance-size ratio.